Hey guys, today we're going to solve LeetCode number 835, image overlap. So we're given two square binary matrices of the same size. We can translate one of the two binary matrices however we want, place it on top of the other image, and count the number of positions where both images have a 1 in that cell, in that position. And we need to return the largest possible overlap. So the way to do this is just a straightforward brute force approach. Just enumerate all of the possible translations and count the number of positions that have a 1 in both matrices. So first of all, we're going to store the length of our matrices in a constant variable. Remember that they are square and they have the same size. Then we're going to store the maximum overlap that we found so far. And later on, we're going to return this. This is our return variable. And now we're going to enumerate all of the possible translations. So what are the possible translations? Well, if you have a 3x3 translation, if you have a 3x3 matrix, you can translate it by 3 steps to the left, 3 steps to the right, 3 steps upwards and downwards. So to enumerate all of those, we're going to first of all enumerate all of the horizontal translations, and we're only going to do the right translations. We're always going to translate to the right, and by starting with a negative amount of steps. That's the equivalent of going to the left. And the same can be said by sliding only downwards. If we slide downwards by a negative amount of steps, then it's also going to go upwards. It's the equivalent of going upwards. So to enumerate those, we use two nested for loops, starting by the negative length. So if we have 3 rows in our matrix, we can slide them by 3 steps upwards or 3 steps downwards. And then at every iteration, we increment the offset that we are using. And the same can be said about the horizontal offsets. So we start from minus length, meaning that we start from 3 steps to the left, and then we go 3 steps to the right, incrementing by 1 at each iteration. And here what we do is we just update our maximum variable, and with the Getoverlap function, we're only going to pass in the row offset and the col offset. And this is going to return us the overlap of this translation, defined by the row offset and the column offset. Right, so that's all there is to it, and now we just need to implement this Getoverlap function, which is just as straightforward as this part, even simpler maybe. So to implement that, we're going to pass in the 2 parameters. And yeah, we're just going to go through all of the positions. So we're going to store the result, which initially starts at 0, and later on we're going to return it. And then we go through all of the positions. So first of all, the rows. So we start from I0, less than length. This is very typical, and increment at every time. And now calculate what the offset position of the row is by just taking the I and incrementing it by row offset, which can also be negative, by the way. Okay, and now check if we are still in the bounds of our array. And if we are, then loop through all of the columns, but if we are not, then we can continue. Okay, so if we are out of the bounds to the left or out of the bounds to the right, or sorry, to the top or bottom, because we're doing the vertical offset right now, then we can continue. We don't have to do anything. But if we are in the bounds, so if we haven't got into this line, so if this is not true, so we are in the bounds, then do the same thing, but for the columns. So calculate what the offset j is by adding the column offset to our standard j. And now do the same thing. Check if the offset j is in the bounds. It's literally the same line. And if it is not in the bounds, continue. But if it is in the bounds of the 2 matrices, then we check if we access the A matrix at the offset I and the offset j, and we check if it is equal to the B matrix at the normal I, so the I that is not offset and the j that is not offset. And if they are equal, then we add to the result variable the A accessed at the offset positions. So if this is 1 and they are equal, results gets incremented by 1. So yeah, that's it. That's the solution, and I'm going to show you that it works. And this is a optimal solution because it is a O of n to the 4th power time complexity solution, where n is the amount of rows or columns, it's the length here. and it is a O of 1 space complexity solution. And what's funny is that if you go in the solution tab of the official LeetCode solution, the first solution here is the one that I've shown you right now, and it has a O of n to the 4th power time complexity in the worst case, and a O of 1 space complexity. But if you go downwards, there are more complicated solutions that have the same O of n to the 4th time complexity in the worst case, and an higher space complexity in the worst case. So yeah, this is the optimal solution. You don't have to do anything fancier. Even the third solution here is the same. O of n to the 4th power time complexity and O of n to the 2nd power space complexity. So yeah, that's it for today. Thank you and bye.